Okay, so in the previous lesson, we learned about alkenes. So let's take a look at the learning objectives of alkene again. Okay, so under this new homologous series called alkene with 2E, okay, it is a homologous series of unsaturated hydrocarbons with a general formula of CnH2n. So unsaturated refers to CC double bond. Saturated refers to CC single bond. Okay, so after that, we also take a look at branch versus unbranched alkene. So unbranched is equivalent to straight chain. Okay, branch is where instead of one straight line, okay, it is forming a T-shaped backbone. For example, something like this. Okay, and same thing, we also take a look at the alkenes with C2 carbon all the way to 4 carbon atoms. So ethene to butene. Okay, for alkenes, we also take a look at how they come about, okay, in terms of the manufacturing of alkenes through the cracking of hydrocarbon. So we will crack long chain of hydrocarbon, okay, from petroleum to manufacture short chain of alkene. And while it is being cracked to form alkenes, hydrogen can also be formed. So this is the source of hydrogen for Haber process in ammonia. So the reason why we crack long chain of hydrocarbon to form shorter chain of alkenes is because long chain are less flammable. They are harder to undergo complete combustion and then they will produce soot. So shorter chain, they are more flammable. That's why the demand for it is higher. Okay, so we are done with the first 3 learning objectives. Then of course, we take a look at the difference between saturated hydrocarbon versus unsaturated hydrocarbon. And we can use a simple test to differentiate these two. So assuming I have 2 unknowns, I don't know which one is alkane, which one is alkene, I will use aqueous bromine. So take note of aqueous bromine, and this is done under dark conditions. Okay, so when I use aqueous bromine, okay, in dark condition, okay, unsaturated hydrocarbon will decolorize my bromine. Okay, so my bromine will become reddish brown to colorless. Whereas for saturated, they can only react with bromine under UV light. Okay, so this is how we do a simple test. So this is one example of addition reaction. Okay, so for alkane, they have CC double bond, and because they have this CC double bond, they are very reactive. Okay, because this CC double bond can just break, okay, and form your CC single bond. So assuming I have this alkene, C2H4, I can break, okay, and then I have one vacancy for this carbon, I have another vacancy for this carbon. So whatever that I react with will add to adjacent carbon atoms. Okay, so the reaction will be addition reaction. It can be bromine, it can be steam, and it can be hydrogen as well. So for hydrogen, it's called hydrogenation, 200 degrees Celsius with nickel catalyst. Whereas for steam, it's called hydration, 300 degrees Celsius, 60 atmospheric pressure, and then I also have my catalyst called phosphoric acid. Okay, and they can also react with themselves to form a long chain called polymer, and they undergo this reaction called addition polymerization. And likewise for all organic compounds, they can undergo combustion to produce carbon dioxide and water vapor. Okay, then we also take a look at real life application of addition reaction, which is hydrogenation. So when we add hydrogen, okay, this is the real life application or industrial application of hydrogenation. So you can manufacture margarine from vegetable oil. Okay, so from unsaturated vegetable oil, you become a saturated product. So usually is your butter, and they are less healthy. Okay, so Vegetable oil, they are very long chain. Okay, in fact, this long chain contains many CC double bond. So when they contains more than one CC double bond, we call them polyunsaturated. So poly stands for many. Okay. So today we're going to learn a new homologous series which contains this OH group. Okay, we call them hydroxyl group. Okay, and similarly, we also take a look at the various members in this homologous series with first one carbon all the way to C4 with 4 carbon atoms. Okay, so we will take a look at from methanol, okay, all the way to butanol. And they also undergo combustion, okay, and we'll take a look at how when it is exposed to air, what will happen to the alcohol. Then we also take a look at how are these alcohol formed. Okay, how is ethanol being formed through two reactions. Okay, the first one is already from alkene, and then how people from all the vineyards, okay, they use sugar, okay, to make alcohol. So fermentation of glucose. And lastly, why do we want to produce ethanol? There must be some uses. So what are the uses? So at this point of time, okay, I hope that we all already know the importance of washing our hands. Okay, why do we need to wash with soap and water? And of course, why do we use hand sanitizer? And what is the major ingredient in hand sanitizer? So for hand sanitizer to work, okay, they will need to have alcohol, and the percentage of alcohol is preferably 70%. Okay, so for why is it so? Because this alcohol, they can dissolve the fatty layer outside the virus. So this virus, the outer layer, okay, to protect the virus, it has this fatty layer. So what this alcohol does is that this hydroxyl group, okay, can help to react, or rather this alcohol group can help to react with this fatty layer acid. So they can help to dissolve and destroy it, and of course damage the virus protein. So that is why your hand sanitizer contains alcohol. Okay, so this is another infographic on how hand sanitizers protect against infection, not just the COVID-19, but all other viruses. Okay, they have all these hydroxyl group. So this is the functional group of all alcohol. Okay, so this is the functional group of all alcohol. And actually it's quite simple to make. All you need to do is to mix alcohol. Okay, usually you'll get a high percentage, then you dilute it with water. Then you add with this thing called glycerol. So this glycerol is like a moisturizer. So when you use it to clean your hand, you don't feel so dry because alcohol can be quite dry. Let's take a look at your notes, page 15. Okay, so inside your notes, you will see this page. Okay, so I would like you to add one more column, which is this portion over here called full structural formula. Okay, so you should have a total of 5 columns, and then the one on the right is the name of your alcohol. So alcohol, they contain this functional group called hydroxyl group. It affects the chemical properties of this homologous series. So for this homologous series, likewise, okay, the naming, the prefix will be the same. Okay, so methanol, meth, stands for 1 carbon. Okay, so followed by the second one, which is called ethanol. And then 3 carbon atoms will be propanol, and 4 carbon atoms will be butanol. So all their names contains this hydroxyl group, okay, which is the name of OL, which is the suffix. So for alcohol, we have this functional group called hydroxyl. So I'm going to draw it under full structural formula. So you take a look at the difference between full structural formula, which is also called displayed formula. So full structural formula is where you show everything. Okay, you show all the bonds, how they are being formed, how they are being bonded from between the atoms. Okay, so 1 carbon atom means I have 1 carbon atom here. I have an OH group, and then the rest of the carbon will be bonded to hydrogen. So in this case, the molecular formula will be CH3OH. So molecular formula is the formula where it tells you how many atoms are there. Okay, now I'm going to introduce this part here with structural formula. Now structural formula and full structural formula is slightly different. Full structural formula, you must show all the bonds. But structural formula, you don't show me the bonds. Okay, so structural formula is a simplified version, and this looks like that. Okay, you might be wondering what's the difference between molecular and structural formula. We'll take a look at it later. Okay, so for ethanol, I have 2 carbon atoms, so 2 carbon, and then I have my OH group. Now, in our homologous series, okay, the functional group will always bonded to the side. Okay, we don't put them in the middle. Okay, now we are learning the simplest version. So we always put the hydroxyl group at the side. Okay, so in this case, my molecular formula is C2H5OH. Okay, notice how I always put the functional group at the side. Okay, so what is structural formula? Structural formula is a simplified version of the full structural formula, and it looks like this. CH3, CH2OH. So this CH3 is here. Okay, this CH2 is here. Okay, and likewise, I will always have my functional group at the end. Okay, so we'll try again. Let's take a look at propanol. Propanol has 3 carbon atoms. Okay, so I also draw 3 first, and then the last one with the OH group. Okay, and I fill in all the hydrogen inside. Okay, so the molecular formula will be C3H7OH. Okay, and my functional group is here. Okay, so my structural formula will be CH3, CH2, CH2OH. So functional group is my OH. Okay, I will have my CH3, which is this part here. Then I have my CH2 in the center, and then I have my another CH2. Okay, so structural formula is a simplified, it's a condensed version. Okay, it shows me how they are being arranged without drawing all the bonds. Okay, so last one, butanol. Okay, so for butanol is 4 carbon. So I will draw 4 carbon atoms. Likewise, my hydroxyl group, I always put at the side. Okay, whenever we learn something, we put it at the side first. Okay, we don't put it in the center. Okay, so we put it at the side and fill in the rest with hydrogen atoms. Okay, so this one is C4H9OH. Okay, and for the next one is CH3, CH2, CH2, CH2OH. Okay, so this is the structural formula. Okay. So same thing in a homologous series from one to another is always a difference of CH2. It's always a difference of CH2. Okay, so the general formula for alcohol is CN, H2N, and OH. Hydroxyl group will be at the end. Okay, so this is not inside your notes for the general formula, so please write it in. CN, H2N, and OH. So this is your functional group. Okay. So when we learn all these homologous series, we are just assuming that there are only one hydroxyl. Okay, so what do I mean by this? So if you take a look at the previous part here, okay, now my glycerol has 3 of them. It is still considered an alcohol as long as you have an OH. So if I have 1 is an alcohol. If I have 2, also an alcohol. Okay, as long as I have this group. But in our homologous series, okay, we learn the simplest form. We learn the simplest form where there is only one hydroxyl and it's a straight chain. So we don't look at the branch chain first. Okay, so let's go back to our slides. So for alcohol, okay, we also take a look at the same physical property in terms of their melting point, boiling point. Okay. So alcohol, they have very low melting point and boiling point. Okay, they are very volatile. And if you take a look at this table over here, okay, as I go down the homologous series, boiling point increases. Okay, and this is because the chain becomes longer and longer. Okay, surface area become bigger. So intermolecular forces of attraction between molecules increases. Okay, so this is your intermolecular forces of attraction. Okay, so please write it down. Okay, now methanol, ethanol, they are also very soluble in water. So alcohol, they are sold for drinking. Okay, they contains a mixture of ethanol or some other alcohol mixed with water. Okay, so they are very soluble, they are miscible. So the only way to separate water and alcohol will be by fractional distillation. Okay, however, when they become bigger and bigger, okay, when their size become bigger and bigger, it's harder for them to be able to dissolve in water. So solubility of alcohol decreases as the size become bigger. Okay, so let's take a look at chemical properties of alcohol. Okay, the reactions. So by now, okay, we should know that all organic compounds will undergo combustion. Okay, they will produce the same product, which are carbon dioxide and water vapor. Okay. So this reaction, okay, is highly exothermic, or rather all combustion reactions are highly exothermic. Okay, so we can actually use alcohol as fuel. In fact, methanol is a clean fuel. In fact, they are cleaner, and compared to petrol, they are less volatile. And another reaction that alcohol can undergo is oxidation. So for alcohol, for wine, for example, if you leave them out in the air for long, the taste will change. Okay, if you leave it out for too long, it will not taste as good. So why is that so? Because they can undergo oxidation. So in this case, oxidation, if you recall redox, is addition of oxygen. So they can react with oxidizing agent, which is your acidified potassium manganate. Initial color is purple. So if this is an oxidizing agent, and they can react with alcohol. So oxidizing agent can react with alcohol. Alcohol is a what kind of agent? Reducing agent. Okay, alcohol is being oxidized, so alcohol is a reducing agent. Potassium manganate is an oxidizing agent. It itself will be reduced. So the purple manganate ions, MnO4 minus, are reduced to Mn2 plus, which is colorless. And in the lab, okay, we can use another oxidizing agent. To oxidize. And this oxidizing agent is called acidified potassium dichromate solution. Do I need to remember this? No need. Okay, so once you see acidified potassium dichromate, acidified potassium manganate, these two are oxidizing agent. Okay, the colors will be from orange to green. Okay, dichromate is from orange to green. Okay, please write it inside your notes. So if you take a look at this reaction here, I started off with ethanol, C2H5OH. I add oxygen, okay, from oxidizing agent. So alcohol will form ethanoic acid. It is a type of carboxylic acid. Okay, it's a type of carboxylic acid. And during this process, water is being produced. Okay, so if you take a look at this equation, you realize that, something new. Okay, you realize that my oxygen is in a square bracket. So why is it in a square bracket? It means that it's from an oxidizing agent. So it's a very simple experiment. I have my ethanol, I have my potassium dichromate, which is an oxidizing agent, and then they will react. And during this reaction, they will produce my ethanoic acid. Okay, I'm using a cold water, okay, to condense my ethanoic acid. So the acidified potassium dichromate is the oxidizing agent. Ethanol is being oxidized, and ethanol itself is a reducing agent. So orange dichromate will turn green. Okay, it will be reduced to form green color. Okay, so this is how it will look like. So from orange, it will become green. Okay, and this is one simple way to test for alcohol content. Okay, and this is how breathalyzer work. So in Singapore, the police will use breathalyzer to test the amount of alcohol consumed by drivers. So if you drink, don't drive. Okay, really, if you drink, don't drive. Okay, because the amount of alcohol that you consume, okay, when you breathe it out, okay, it will also contain the alcohol, and this will result in a color change in the device. Okay, so what is happening inside this breathalyzer is that you have your ethanol. Okay, you have your ethanol, which is C2H5. Okay, you have this oxygen from oxidizing agent. So this and this combined, total you have 2 units of oxidizing agent, oxygen from the oxidizing agent. So you will require 2 oxygen atoms from the oxidizing agent, and you will form your carboxylic acid. This is your ethanoic acid. Okay, of course you don't need to know this intermediate step. Okay, however you need to take note. Okay, this ethanol, okay, react with 2 units, okay, will form ethanoic acid and my water molecule. So water molecule is being formed. Eventually this hydroxyl group, okay, will form this group called carboxylic group. Okay, C double bond and 1 OH. Okay, so the hydroxyl group is being oxidized to COOH. Okay, so let's take a look at this video, okay, to see how the reaction occurs. So I have my ethanol, which is colorless. Okay, I need to acidify with my sulfuric acid. Okay, so this oxidizing agent, the initial color is orange. So I acidify the oxidizing agent, okay, mix them together, and I speed up the reaction by heating it up. Okay, observe the color change. Initial color is orange. So observe now it's green color already. Okay, so now it's orange to green. Okay, next part, okay, we'll take a look at how to produce ethanol. So there are 2 ways. One of them is addition of steam to ethane, and this is your hydration. Okay, this is your hydration, right? Another step is fermentation of glucose. Okay, so we'll take a look at these 2 ways. First one, in the lab, okay, we can actually do a simple reaction where we use phosphoric acid, 300 degrees Celsius and 60 atmospheric pressure to react steam to ethene. So we call this hydration. Okay, we use ethene. Okay, then we add steam. Conditions right on the arrow. Okay, so this double bond will be broken and the water molecule will be added to ethene. So the H will go to one carbon, the OH will go to the other carbon, and they are added side by side. So this is hydration. Another way to prepare ethanol in the lab is by the fermentation of glucose. So what they do is in factories, okay, they produce alcohol such as wine and beer using fermentation of glucose, and they are done using these big barrels. Okay, so wine and beer, they contain ethanol, and to produce ethanol they use fruits, vegetables or grains, and they ferment it. They ferment it with microorganisms such as yeast, okay, to break down these fruits and grains and vegetables, the sugar in them, to form ethanol and carbon dioxide. So they do this in the absence of oxygen. And during this process, you will see foaming. Okay, so they call it froth. okay, where it's like bubbles of carbon dioxide. So in the lab, we can also do that. Okay, we do it in the absence of oxygen by ensuring that they are kept. Okay, and they do it in a temperature of 37 degrees Celsius because yeast, they work best at this temperature. Okay, so they have to keep it at this temperature, which is the optimal temperature. If it's too high, if the temperature is too high, they will denature. Okay, so maybe you write this down. Greater 37 degrees, yeast will denature. Okay, denature means they will be destroyed. Okay, because yeast is a form of enzyme. Enzyme is like our proteins. Okay, so in our body, when our body temperature is too high, the enzymes in our body also cannot work. They will denature. So that's why it's important to keep at this temperature. Okay, and during this process, they will produce carbon dioxide and ethanol. How do we know that carbon dioxide is formed? Is because they see bubbles, and when there's bubbles, they test for the gas. They test using lime water, and they see what precipitate. Okay, so frothing will observe. Frothing is another word for foaming. Okay, so they have to do this in the absence of oxygen. So the question is, why? It's something that we have learned earlier on. So I hope that you pause and think why. Okay, during this reaction, ethanol is produced. And when there is oxygen, ethanol, okay, can be oxidized to form ethanoic acid, which is something that we don't want. Okay, we want to have the alcohol, we don't want the acid, because the acid, the sour taste will spoil the taste of the wine or taste of the beer. Okay, so that is why this is done in absence of oxygen. If oxygen is present, alcohol will be oxidized. So in this fermentation reaction, okay, ethanol will be produced and the reaction will stop once it's 15%. So it's we are unable to form 100% ethanol via this process. Okay, because once it's more than 15%, right, the yeast will be killed. Okay, so concentration is about 15%. And how to separate glucose plus yeast plus ethanol? Okay, after you react, you will have ethanol, right? About 15%. How to separate them? You separate them via, how do you separate them? They are all mixed up together. What kind of separation technique? You will separate them via fractional distillation. Okay, so you obtain the ethanol via distillation. And last but not least, why is it that we need to produce ethanol? Okay, other than being produced for your alcoholic beverage purpose, okay, it's also used for fuel. Like I say, it's a cleaner fuel. Okay, it's a cleaner fuel, less volatile. Okay, less volatile means less dangerous. Okay, and then it's also used for solvent like paint, varnishes, perfume. So those paints, okay, you can smell the paint very quickly because they are volatile. They will just evaporate very quickly from liquid state to gaseous state. Okay, and of course, ethanol, you can further oxidize it to make ethanoic acid to preserve food. Okay, so what we learned today is that alcohol is a homologous series, which have this group called OH group. And this OH group is called hydroxyl group. So we also take a look at the structures. Okay, we take a look at what's the difference between structural formula versus full structural formula. Then we also take a look at the properties of alcohol. Okay, what are their physical properties, and then of course their chemical properties. They will always undergo combustion, or organic compounds do, and then they will be oxidized to form the next homologous series called carboxylic acid. Okay, it contains 2 oxygen atoms, whereas for alcohol, they only contain 1 oxygen atom. Okay, and we also take a look at the 2 ways to produce ethanol. One of them is steam. Okay, adding of steam, which is called hydration to ethene. And then the last one is fermentation of glucose using yeast at 37 degrees Celsius. Absence of oxygen. Okay, and last part, very briefly, we take a look at the uses of ethanol. Other than it being alcoholic beverage, it is also used as a fuel. Okay, so that is the end of the homologous series of alcohol.